Bismillahirrahmanirrahim. Allahumma salli ala Muhammadin wa ala ali Muhammad. Dear students, I'm, as you know, Abda Hamid, Associate Professor of Chemistry. And today our topic of discussion is isomerism. And particularly, we will focus on enantiomers. What is isomerism? The relation of two or more compounds, radicals or ions, that are composed of same kind and number of atoms, but they are different. How they are different? Structural arrangement. They are different in structural arrangement or in arrangement of their atoms in space. Dear students, we will now discuss one by one all the types of isomerism. Some are present in the syllabus of first year and some are present in the syllabus of second year, but both collectively you will face questions from all of these isomerism in your examination, MCAT वगैरह, MDCAT वगैरह, etc. etc. जी, isomerism may be of two types, structural, and structural is further divided into chain, positional, functional, metamerism, tautomerism, and right chain. The second type of isomerism is called stereoisomerism, while stereoisomerism can be further divided into configurational isomerism and conformational isomerism. First of all, we will discuss, we will focus our attention on configurational, which are of again two types, optical isomerism and geometrical isomerism. Dear students, structural isomers differ in their connectivity, means the different isomers have different type of connection. For example, look, this is a carbon chain and your group or branch may be attached with this carbon number 1 or with carbon number 2. That means connectivity is different. In one isomer, it may be attached with one carbon. In other isomer, the any group may be attached with carbon number 2. Similarly, stereoisomerism, how stereoisomerism is different from the structural isomerism? As you have seen, in structural isomerism, connectivity of the group changes. It may attach with one carbon, may attached with second carbon. But in stereoisomerism, we will say connectivity remains the same. Just orientation in the space changes. Look, whether the group attached may be orientated in this way, and in second isomer, this group may be orientated in this way. You can see here, connectivity is with the same carbon, carbon number 2, but orientation in space has changed. Similarly, it may be down or may be up. These two isomers will be different and they will be stereoisomer of one another. Now we will explain structural isomerism, chain isomer, positional isomers, functional isomers, metamerism, and tautomerism, and finally right chain isomers. Chain isomers. This type of isomerism is shown when carbon atom have different branches. For example, you can notice here this is N-pentane, straight chain, and similarly now there is one branch and this is called isopentane, and with two branches this is new pentane. All these structures have their IUPAC names also, but as we are discussing at this time isomerism, we can notice here all of these three compounds have same molecular formula, that is all have 5 carbons and 12 hydrogens, but all are different in their structure, and this type of structural isomerism is called chain isomerism because you can note here chain is different. One is straight, one is one branched, the last is two branched chain. Similarly, here is the another type of structural isomerism called position isomerism. You can check here. This is pentane 1-ol, pentane 2-ol, pentane 3-ol. So what is the difference? Functional group has different positions. So this is called positional isomerism. And we can also check here this example again in this manner, that all you can check all are 5 carbon chain, but in one carbon OH group is attached with first carbon, and then it is attached with second carbon, and it is attached with the third carbon. So position of the functional group is being changed. So this is called positional isomerism. And maybe any other functional group, and maybe here chloride, bromide, maybe amino group, cyanide group, any group maybe change its position. So this is type of functional, no, this is type of positional isomerism. And then functional group isomerism. In this type of isomerism, students, you will note that molecular formula is same, but the functional group is different. For example, you can check here, this is ether and this is ethyl alcohol. Both have 2 carbons, 6 hydrogens and 1 oxygen. Same molecular formula, but both have different functional group. So this type of isomerism is called functional group isomerism. Similarly, metamerism. Metamerism is a type of isomerism in which you will notice that functional group is the same, but the chain across the functional group, chain length is different in different isomers. For example, look at here. This ether is called ethoxypropane, and this ether is called methoxybutane. But all of these two isomers have same molecular formula. These have 5 carbons, similarly 12 hydrogens and 1 oxygen. But both are different isomers. You can check this is, what is the difference here? Here, this there are 2 carbons present on the left side, 3 are on right side, but here 4 are on right side and 1 is on left side. So chain length across the functional group uh, is different, and this type of metamerism is also shown by ketones in ketones. uh, Functional group may present on 2 carbon or 4 carbon, etc. So different lengths will be present on right and left of the functional group. So what are functional group isomers? Isomers differ in no, sorry, what are metamers? Isomers differ in uh, chain length across the functional group. And this is tautomerism. And tautomerism is also known as tautomers are also known as keto and enol isomers. Check here, this is enol. Why it is in double bond? Ol alcohol. When in ethine water molecule adds, this type of product is formed. This is called enol. So in enol, what happens? Internal rearrangement take place, which is also reversible. What type of change will take place? I am showing you. This double bond is transferred between carbon and oxygen, while hydrogen with oxygen comes from detached from oxygen and make bond with the carbon. So an aldehyde is formed. A ketone may also form here, but in this case particularly the species formed is acetaldehyde. And this type of isomerism is because reversible. Enol form changes into keto form changes into enol form. So both forms exist in the solution. Then right chain isomerism, look, it is the isomerism. This is 1-butene and this is cyclobutane and this is methyl propane. All these three has you can check here, all these three has same number of carbons and this carbon number is 4 and these have number of hydrogens that is 8. But the structure, how this is differing? This is differing. One, there is a straight chain. Another place, this is a cyclic compound.